Hi, today I want to talk about the fundamental theorem of calculus. And as the name states, it's a very important theorem. But there are actually two fundamental theorems of calculus. The one that I want to focus on is typically called the second fundamental theorem of calculus, but some textbooks might also call it the first one. It doesn't really matter. The fact of the matter is that this is a very important theorem. So, you might recall from calculus that um, for the fundamental theorem of calculus, you need a continuous function. So continuous means that you can draw the graph without picking up your point. So something like y equal to x is a beautiful continuous function. Y equal to x squared, that would be a beautiful continuous function. So you need some continuous function in order to apply this theorem. And then what it tells you is that if you take a look at the antiderivative of a function f, this continuous function, so little f, that is going to be your continuous function. And let's define the antiderivative of that function as capital F. Then the derivative of this whole integral from a to x of that function f of t is evaluated at the point x. So remember, this integral goes from a to x. Then that is just going to be f of x. So this is very helpful, especially if you have quite a complicated function. So let's see. We have that f of x is equal to the integral from minus 5 to x. So you can see this as the integral from a to x here of t squared plus sine of t dt. So first of all, we need to make sure that we can actually apply the fundamental theorem of calculus to this function. Well, t of squared, as I said, that's a beautiful continuous function. Sine of t, well, it looks like this. It's a beautiful continuous function. And we know that the sum of two continuous functions will be continuous. So this is in fact definitely continuous. So we know that we can apply the fundamental theorem of calculus to this. So we want to know if this is how f of x is defined, what is going to be the derivative? Well, we're just going to apply this directly. So then the derivative is going to be exactly what the f of x is. So it's going to be x squared plus sine of x. And that is how easy it is. So just wanted to make sure that you recall this theorem, a very important theorem. Thank you.